so just like the difference of squares, you can factor perfect cubes. But the difference is, for the squares, it has to be a difference of squares. For cubes, it can be both a sum or a difference of squares. And these will always have the same pattern, where whatever's being cubed and whatever's being cubed here, it'll factor into those two terms, so a plus b, and then you square it, a squared, you multiply them together, ab, and the last term is always the b squared. It'll always be this, if it's a sum or difference, that's the pattern. ab, a squared, ab, b squared. The difference is the signs, and the way to remember the signs is a little thing called SOAP. So the first sign is always the same. If this was a plus, now that's a plus. The next sign is the opposite. So this was the same, this is the opposite. So if this was a plus, now it's a minus. The next two stand for always positive. So you see that these two are always positive. So the first sign is the same. The second sign is the opposite. So this was minus, now it's plus. And the last one is always positive. Alright, so let's try factoring. First I have to figure out what is being cubed. So x is being cubed and 2 is being cubed. 2 times 2 times 2 gives me 8. So this is my a, this is my b. So it's always going to go into a minus b, so same sign, a squared, the opposite sign, this will be plus ab, and then always positive, b squared. Now I plug these in. I plug in x everywhere I see an a, I plug in 2 everywhere I see a b. So x minus 2. And then x times x is x squared. And multiply the 2 together. So just the 2, not the sign here. I already know what the sign is going to be. So 2 times x is 2x. And the last one, 2 times 2, is 4. And that's as far as you can go with a difference of cubes. Let's try it again. Sometimes we forget that this is a cube, right? So if I'm cubing it, that means something times itself 3 times. Or b squared times b squared times b squared. It's going to give me b to the 6th. So I add them. 2 plus 2 plus 2 gives me 6. So what's being cubed here is b squared. 125 is a perfect cube. 5 times 5 times 5 would give you 125. And y is being cubed. So again, you're essentially taking a cube root. For an exponent, you would divide by 3 to figure out what this is. You would have to factor the 125 to get the 5. And then, again, you're taking out the cube here. So this is my a, b squared is my a, 5y is my b. I fill it in my formula. Now this one's a positive. So it's going to go a plus b, same sign, a squared, the opposite sign, ab, always positive, b squared. Alright, I fill it in. So everywhere I see an a, I'm filling in b squared. B squared, everywhere I see a b, I'm filling in 5y. That's 5y. I'm going to square it. So b squared times b squared is b to the 4th. Multiply the 2 together. So 5b squared y. Again, I just write the coefficient first and then alphabetically. And then the last term squared. 5y times 5y is 25y squared. And that should be as far as you can go with a sum of cubes. Alright, last one here. It says 2m to the 5th plus 2m squared. Do you see it? Do you see what we need to do first? GCF. Okay, so first I'm going to take out the GCF. I see they have a 2 in common, and they also both have m's. So I'm going to take out an m squared, because they both have m squared. I take out my GCF, 2m squared. I divide this out, I'll have m cubed. This divides out, and this divides out. It's not 0. Anything divided by itself is 1. A lot of times students think they're done here. But what's tricky is 1 is a perfect cube. 1 times 1 times 1 is still 1. So now I have m cubed and 1 cubed. I have a sum of cubes. So I need to factor it. It's going to go a plus b, same sign, a squared, opposite sign, ab, always positive, b squared. So I fill it in so that the GCF stays the same. My a will be m, my b will be 1, so m, erase some of this stuff. Not eraser for me. Pen. Alright, so m plus 1, then I square it. M times m is m squared. Multiply them together. 1 times anything is itself. And then square it. 1 times 1 is still 1. And that is totally factored. So here's a summary. We have a sum of cubes, so if I see two terms, I need to ask myself, are they perfect cubes? Are they perfect squares? The sum and difference of cubes can be factored, and only the difference of squares can be factored. A sum of squares cannot be factored, and let's check for y. So let's say I had x squared plus 4. A lot of times I get the answer x plus 2 times x plus 2. But if I multiply that out, I'll get x squared plus 2x plus 2x plus 4. I'm going to get 4x in the middle, but I don't want 4x. So let's try something else. Let's try x minus 2 times x minus 2. Well, it's going to be the same thing. I'm going to get x squared, and then negative 2x minus 2x will be minus 4x plus 4. So I've still got something in the middle. The last one you could try would be plus and minus. But, oh wait, we already know when we multiply conjugates, I'm going to get a difference of squares. So there's no way to break down a sum of squares. Okay? It's not factorable, it's prime. So the only three you have to look out for are a sum of cubes, a difference of cubes, and a difference of squares. A sum of squares is always prime.